The nature of light has been a subject of reflections for all of human civilizations, Greek, Indian, Arabic. Among the most modern scientific theories, there has been a permanent debate between the wave or corpuscular nature of light.
Who was Thomas Young? Thomas Young, Somerset Street, Great Britain, 1773, London, 1829, Bristol century. Born into the Currer family, he studied medicine in London. 1792, Edinburgh and Covington were in graduate. In 1797, he became a professor at Cambridge University. From there he went to London, 1799. In 1801 he was professor of natural physiology at the Royal Institution. Despite until 1814 he continued to practice medicine.
Young double slit experiment. Young pays a beam of light through two slight and Sagan interference pattern appear on a screen. Observes of alternating bright and dark springs. The reason is inexplicable in light where made of particles because on two frames of light should be observed in front of the lids, but it is easily interpreted as assuming the light is wave and that suffer from interference. The experiment can be performed with electrons, atoms of neutrons, producing interference patterns similar to those obtained when performed with light. The interference showed the wave-like behavior of the particles. What was proven was, thanks to Thomas Young's experiments, it was shown, in contrast to Isaac Newton's theory, that the view of light when traveling through space was wave written as corpuscular.
Performance of the double slit experiment. As a final part of the double slit project, we have as a team to carry out this experiment and try to emulate the results obtained by Thomas Young in 1801. In the case, each member of team will try to replicate the experiment individually, hoping to find the desired results.
Concepts to consider. Construct interference. When sine waves are in phase, the crescent throws of one are aligned with the crescent throws of the other. The interference is constructive and the resulting waves has a higher amplitude. The stroke interference when sinusoidal waves are out of phase. The crests and troughs of the waves are not aligned and differ from each other. The interference will be destructive, which will cause a decrease in amplitude of the resulting one. Feedback of the results of Thomas Young. What Thomas Young accomplished with this experiment was to demonstrate the wave nature of light. He managed to prove that under the right conditions, light beams can combine or cancel due to constructive and destructive interference. Hypothesis. By performing the products correctly, we will be have to project a pattern of light beams with maximus and minimus on a screen due to constructive and destructive interference characteristics of waves. Below is reference image of the desired result. Synthesis particles photons of a specific wavelength will be projected on screen through two slots. Going through the slots, the image of the particles photons will become visible with an interference pattern, constructive and destructive, with maximum and minimum. To carry out the experiment successfully, three elements are required. 1. The source of particles or light. What we need to successfully reproduce an interference pattern into particles of the same energy or photons with the same wavelengths, since the wave reaches to single wave pattern with well-defined bands. 2. The double slit. The slots should have a length equal to or slightly greater than the wavelength of the particle source. 3. The screen where the image of the particles will be projected. This only requires a surface where the photons are reflected in a legible way, preferably a dark surface.
Test 1. Materials. For this phase test we use the following materials. 1. Light source on particles hand lamp. Light type LED. Power 3000. Due. The double slit cardboard structure wide 0.5 por 0.2 perforations for the slit. The first stroke with one slit and the second with two slits. In the background, the screen where the light will be projected. Process. The first test was carried out and the light was projected to rock the first slit, and the beam of light can be string the middle on the next two slits. However, there was no success in training the project. The light particles I expected. The result was negative as only a beam of light was projected in the edge of screen. A second attempt was made with external light source. The we was expect that this was the race, while the light pattern cloud not be clearly visible. But contrary the what was strong, the result continued to be negative. Not finding a positive result, I was decided to test which different wavelengths on the project light. Even so, the result did not change. Conclusion. After an analysis on the result, I was conclude that possibly the wavelength on the particular source did not compensate for the lag and distance with respect the slow drop, which they did project. We believe they addition the bank and very scattered. We blink
that comes out on the source. The balance with respect on the size and distance of the slots, causing an increment in destructive interference, which means that the only beam of light type project on the script and the one that travels strike through the slot.
Test number 2. Materials. For the second test, a change in the methodology was considered, as well as in the materials to be used. For this, the following materials were used. Number 1. Light source or particles. For this, we use a laser pointer. Lasers manage to produce photons with a very specific wavelength, which, we believe, will be essential if we want to successfully replicate this experiment. 2. The double slit. For the base of the double slit, a microscope slide was used and one face was covered with aluminum foil. The structure of aluminum foil makes it easy to be torn in one direction, preventing it from breaking. Number 3. The screen. Basically, for the screen we use a black sheet located at some distance from the double slit and the photon source. Procedure. Once the necessary materials for the experiment have been obtained, we proceed to test it. We place the laser at 15 centimeters from the double slit, and this in turn has a separation of 1 meter with respect to the screen where the photons will be projected. Now that we have everything in position and with the fixed distances, we proceed to make the first shot with the laser. Pretty close, although some diffuse, the result obtained is quite close to what we want to obtain, because the pattern of maximums and minimums is now visible. To improve the result, we will modify the distance of the shot and the distance between the slits. To achieve a proportional length between the distance of the slits and the wavelength of the laser, a measurement in microns is necessary, so we choose to trace the slits as close as possible to each other. Second exhibition. Once the distance between the slits has been adjusted, we proceed to make a second laser shot. In this second shot, with the adjustments mentioned above, we have to achieve a satisfactory result, with a pattern of maximums and minimums typical of constructive and destructive interference. Result achieved successfully. Conclusion. Test number 2 was successful. Thanks to the observations we were able to reach with the first test, the change in the materials and measurements of the slits were very helpful to achieve the result. As Young described in 1801, we can observe the dual nature of light, which demonstrates that it has a corpuscular and wave behaviors.
My name is Axel Emmanuel, and my participation was to put the voice for the audience. And what I learned was something that light not notes but is logical, and that is why the lights and wave and the experiment was the purpose of rejecting the theory that the lights was formed by particles.
Hello, my name is Daniel Antonio. I took care of the video editing. My learning on the subject is that this experiment was designed to answer the question of whether light had a particular nature or rate considered of waves. In this experiment, the wave nature of wave was demonstrated.
Hi, my name is Jose Francisco Lopez Barrera. In the experiment, I learned many things. I learned to work as a team. I discovered how amazing replays can be.
Ivan Sanchez. My participation in this project was based on the feedback on the theoretical part of the experiment, as well as inquiring a little about Young's background and the reason why he performed this experiment. I also took part in the practical part of the project, adjusting for the second test shown in this video and capturing results and evidence. As a personal conclusion, I can comment that this issue and made us understand that the nature of the light is much more complex than initially thought when this phenomenon was just beginning to be studied. Many properties and characteristics found in this experiment are considered a basis for what is called quantum physics. And thinking about it is super interesting to me. Thank you.
Comment Diego Zavala Velazquez. The double slit experiment is a demonstrate that light and matter can display both classically definite particle and wave characteristics. Furthermore, it shows the fundamentally probability nature of the phenomena of quantum mechanics.